All right, well, welcome to lesson 5.3. We're going to be looking at double angle and half angle formulas. So those are the two objectives that we're going to cover in this lesson. So those are the double angle formulas. Copy them down. You're going to use them on the examples and then in the practice that we do. So in a lot of ways, this lesson is similar to previous recent lessons in that you're going to work with some formulas to convert things to other things. So this one says if sine of theta is equal to 4/5 and theta, so the angle, lies in quadrant 2, find the exact value of sine of 2 theta. So the first thing you do is figure out, well, if sine of the angle is 4/5, remember sine is opposite over the hypotenuse, then you need to find that other side. You need to find what the x value is. So y would be 4, r would be the hypotenuse or the radius of the unit circle would be 5. And then you're going to solve for x. You can use Pythagorean theorem or know that this is a special right triangle, which is a 3, 4, 5. The reason why it's negative is because we're talking about the second quadrant. And in the second quadrant, x is negative, y is positive. So sine of theta would equal y over r, which is 4/5. Cosine of theta would equal x over r, which is negative 3/5. Right? Sine of 2 theta using the formula that we just learned is equal to 2 sine theta cosine theta. So 2 is 2. Sine of theta was given as 4/5. Cosine of theta is what we just figured out, which is negative 3/5. When you multiply all that together, you get negative 24/25. All right. The next one is essentially the same question. We're just now looking for cosine of 2 theta. So the first half of the work over here is identical. You're just figuring out what is the x value, so that way you can know what the cosine theta is. And it's negative 3 is x again, so the cosine of the angle would be negative 3/5. So that part is identical to the first example. Now the difference is, since the question is asking you for cosine of 2 theta instead of sine of 2 theta, is the formula that you're going to use. So cosine of 2 theta is equal to cosine squared theta minus sine squared theta. Well, cosine theta is negative 3/5, so squared would just be squared. And then same thing with sine squared theta. Sine theta is 4/5, so you would square it to get sine squared theta. You end up with 9/25 minus 16/25, which ends up being negative 7/25. Again, basically the same question, same setup, but it's now asking you for tangent of 2 theta. So again, you can get the x by getting negative 3/5. Tangent of 2 theta is equal to 2 tan theta over 1 minus tan squared theta. In this case, remember, tangent is y over x, right? So y is 4, x is negative 3. So tangent of theta is negative 4/3. All right, so it's 2 times negative 4/3 over 1 minus negative 4/3 squared. And then to continue that, and I'm basically just simplifying that expression. On the next slide, and you end up with negative 8/3 over negative 7/9, which reduces to 24/7. These are other forms of that cosine 2 theta. So the top line here is what you've already written down. These are just other forms of it that you may find useful in the practice. So I would write them down as well. All right, the other half of the objective was using the half angle formulas. So you have one for each of sine, cosine, and tangent. So sine of half of an angle is equal to plus or minus 1 minus the cosine of the angle divided by 2. All right. For cosine, it's 1 plus cosine divided by 2. Then for tangent, it's 1 minus cosine of the angle over 1 plus cosine of the angle. You're not, for all of these, obviously, since tests are open notes, you're not really being forced to memorize any of this, but just you're going to be tested on how to use it, right? So have these formulas available to you as we do the rest of the examples in the notes, and then as you start the practice. So find the exact value of cosine of 105 degrees. So cosine of 105 degrees, you could rewrite as cosine of 210 over 2, right? 210 over 2 is the same thing as 105. So if I use the formula for the half angle of a cosine, cosine of alpha over 2, well, in this case, the alpha is going to be 210, right? So you're really just substituting 210 in for the angle. So you end up with 1 plus cosine of 210 over 2. Cosine of 210 is negative root 3 over 2. The reason why this is useful is 105 degrees is not one of the special spots on the unit circle, but 210 is, right? Because it's 30 degrees past 180, right? So it's one of the 30-degree angles, just in this case, the third quadrant, which is why this is negative. And then in order to, so this, the left side here is what was on the previous slide. You have this, the opposite of the square root of 1 plus negative root 3 over 2. That just needs to be rationalized. So they're multiplying numerator and denominator by 2. So you end up with, well, distributing the 2 in the numerator, and then 2 times 2 is 4 in the denominator. The reason why we multiplied by 2 is to make it a square number. Square root of 4 is 2. So notice how now there's no square root in the denominator. So you end up with the opposite of the square root of 2 minus the square root of 3. You can have a root and a root like that. That's okay. But you just can't have a square root in the denominator, which is why this is simplified. There are some additional half-angle formulas for tangent that you may come across. Again, as you start the practice, certainly. Sorry, my dog is barking. So you might see these formulas. So I'd write these down as well. If you need help with applying any of these, that's what the breakout room is for. I'm going to leave this question as an exit ticket. So please try this question as an exit ticket, and we will go over this together in class. So give it a try, and then there we go. Let me know if you have any questions.